We're going to start our next lecture, which is on flags. So again, before we start the lecture, let's review all the registers. We have been working with the registers for a while now. So we know the accumulators, we know some other registers. We don't know the purpose of all of those. But today we'll be talking about the very last one here on the list, which is the condition code register. In short, it's called CCR. So this is actually the register, which is a 1-byte register, and as you can see, we have 8 bits in the register. But unlike the other register, this register is controlled by the microprocessor instead of controlling by us. Okay? Because most of the registers, what do? You load data, or you just do some operation with those, writing the instruction. But this register is actually operated by the microprocessor. You can still handle the register, but it's mostly controlled by the microprocessor. Now, why microprocessor control it? A lot of times what happens, you have probably already seen, let's say you are doing an addition, and what happens? You had a carry, which was dropped, right? Because you could not accumulate it in the accumulator, okay? You could not, put it on the register. So, but the point is, if the microprocessor has to drop something sometime, that means that the operation will not give you the right answer, okay? So the answer you will be getting is not correct, but microprocessor cannot fix it, but microprocessor can let you know that, okay, we had an operation and you had an error, okay? So that means through these flags, microprocessor actually tells us whether the last operation was done perfectly, correctly, or not, okay? So a lot of times things are out of the control of the microprocessor, like the ones as you have seen that, let's say you are trying to save something more than 1 byte in accumulator. So accumulator A and B are 1 bytes each. You cannot put it there. So microprocessor had to drop something. So you will probably never know microprocessor had to drop it unless microprocessor tells you in the flags. So whenever something happens, microprocessor always tell it there, okay, something is wrong. So that means microprocessor cannot fix the problem, but microprocessor can tell, oh, something happened, okay? An error occurred. So today we'll mostly talk about the last 4 bit here on this list. So all of these are called different flags. So for an example, the first one is called N flag. All of these are actually called condition bits because these actually represent some condition, right? This indicates some condition which was basically set by microprocessor, controlled by microprocessor. So this is N flag, the next one is called Z flag, V flag, and the last one is C flag, okay? So today we'll talk about all these 4 flags, okay? And then we'll also try to see what are the conditions for these flags to be set or cleared. Okay, now what happens with these flags? Now, again, as you have seen, these are binary bits, right? So that means this can store some condition values, and since those are binaries, the condition values can be either zeros or 1, right? Nothing else, because it's binary. You don't have any other choice. So that means the condition bits can be changed to 0 or to 1. So when the bit is 1, we call the condition is set, okay? When the bit is 0, we say the condition is cleared. You see what I'm saying? So number 1, that means 1 is set, 0 is clear, okay? And both has meaning, okay? If it is set, it has a meaning. If it is not set, meaning cleared, it has a separate meaning. We'll talk about those soon. So basically, all these condition bits changes due to instructions. That means due to the instructions you have in your instruction set. Whenever you run those instructions, meaning your microprocessor run those instructions, the condition bits change based on the outcome of the operation, okay? So let's try to understand those bits a little bit more detail. So we'll talk about one flag at a time. Let's start with the very rightmost one, which is called C flag, and also called carry borrow flag. In short, we call it C flag, but most of the people know it by carry flag, okay? Now, let me show you a quick example that how the carry flag can be set. Let's say we are doing an addition, okay? Now, the addition produces a carry of 1 at the very end, like this one here. Let's say you are adding 83 and 9a, and in hex, and you got a carry at the very leftmost left side. Okay. Now, if this happens, if you have a carry at the very end, then your carry flag will be set. That means your microprocessor is letting you know that, okay, whatever you did in your last operation, you had a carry. You probably will not see this carry because the carry will be dropped before you save it, right? Because let's say you are trying to store this sum into accumulator A or accumulator B. That means this one will be dropped even before you save it. So you will never know whether you had a carry or not. Unless you check the flag, you will know that there was a carry. Okay? Carry flag can also be set in case of subtraction. Now it happens when your subtraction is something like this one, that you are subtracting 9A from 83. Now what happens in such cases? If you are subtracting something like this, you actually have to borrow something from outside, right? Why? Because the minuend is lower than your subtrahend, right? See, the minuend is 83 and subtrahend is 9A. So you will always have to borrow something from outside. I'm saying we do it logically. We borrow a 1 logically from outside. If you have to do such thing, that means your carry flag will be set also in case of subtraction. Now remember, when you will be doing this in your calculator, remember we have a digital calculator in our computer, and we do all those addition, subtraction in our calculators, you will actually see a bunch of F at the beginning of this E9. You'll see a bunch of F followed by E9. So that means you know that you actually had to borrow, and it's actually keep borrowing all the way. Any question about the C flag? So these are two conditions when the C flag is set in case of addition and subtraction. Okay, I think this is actually the easiest one. Let's look at the next one, AND flag. We are not following the sequence. We are just doing a little bit random ones, but we will be covering all this four. This is called negative flag, and as you can guess from the name, this flag is set when the result of meaning the outcome of the last operation is a negative number. You may be doing an addition, subtraction, or something else, but your result can be negative. Whenever the result is negative, meaning the outcome is negative, this flag is set. And for the same reason, this flag is cleared when the result is not negative, meaning positive or 0. Okay? Now, let's recall, how do you identify the negative number? Let's go back to the digital circuit class. Remember we learned the number system, and at the very beginning we learned how to represent the negative number. What happens in the digital devices, we don't have any place where you put the sign, right? So instead we just convert any number to 2's complement, which is actually the negative form of the same number. Okay? Now, to make it simple here, to make it very simple, how do you know a number is negative? If it is a binary number, because a lot of times you write in binary or sometimes write in hex, right? If you have a binary number, that is negative if the leftmost digit is 1. Very leftmost digit is 1. Okay? Then that is a negative number. If it is a hex number, that can be negative if the leftmost digit is 8 or more, meaning 8 or 9 or A, B, C, D, E or F. Now how do I know starting from 8 is negative? Think about 8. 8 is the first hex digit. If you just keep counting from the 0, 8 is the first hex digit which starts with a 1 in binary. How do you know what is 8 in binary? 1, 0, 0, 0. So that is actually the first number where the leftmost bit is 1. Okay? So this is two different ways you identify a number is negative. If it is a binary number, the leftmost bit must be 1. If it is a hex number, the leftmost digit must be 8 or more. What does it mean by more? 8 or 9 or 10, meaning the A or B or C or D or F. Okay? Those are the negative numbers. Now that means, remember, it has to be the leftmost digit. It's not all the digits, just the leftmost digit. Okay? Now, and as you can guess, the negative flag is always cleared if the result is positive, right? Or result is a 0. Any question here?
I'm curious. So if I just see, I'm still trying to think about how would you differentiate seeing a negative number if the leftmost digit is binary versus just if it was just a normal.
Just the leftmost digit is 1.
But if it's just a normal binary.
What do you mean by the normal? You have to define the normal here, okay? By default, the computer represents, meaning the digital device represents all the number as signed number by default. So everything is signed by default, okay? Unless you mention something is unsigned. I'm not sure whether you have seen this since you have been in the C++ class and you tried some programming, right? Did you see that in C++ class there was a keyword called unsigned? Have you ever used it? You may not, right? But you may have. So let's say if you define integer, you know, you have to define the variables, right? At the very beginning, you know, at least before you start the, you know, using it, you have to define it. So when you define like integer x, by default x is signed. But if you really want to use x as unsigned, you can write unsigned int x. Then it actually treats the number as unsigned number. That means by default, your number is signed. Now this is what happens. If you are using an integer, it is always signed. That means, what does it mean by it is signed? That means it can range from 32,767 to negative 32,768. Okay? Because if it is all ones, then it's actually 32,767 when it is all one, because integer is 16-bit, right? 2 byte. If it is all ones, meaning 16 ones, indicating the leftmost digit is 1. Let's recall how you identified the negative number in the digital circuit class. Remember in the digital circuit class at the very beginning, we tried to identify the negative numbers, right? In the sign format. We're exactly telling the same thing here, okay? Now, to make it simple, I just said, okay, if it is a binary, just check the very leftmost digit. If it is 1, then it's leftmost digit means what? That bit number 7, right? Because you count from bit number 0 and go all the way down to the left side. If you go all the way down to the left side, the very leftmost digit would be bit number 7, which is 1. And in case of the hex number, if the leftmost digit is 8, okay, or more. We'll show you some example, okay? Let's look at the next flag. The next flag is an easy one. It's a 0 flag. And as you can guess from the name, 0 flag is set when the result of any operation is absolute 0, meaning 0, 0, okay, in hex. Then 0 flag is set. Otherwise, 0 flag is cleared. See, any operation affects this flag. I'm saying operations that affect this flag will always change it, meaning if the result is even not 0, it will change it to cleared, right? So it actually clears the flag. Any question about the 0 flag? We'll show you some example again. Let's look at the very last one for today, which is called V flag and also overflow flag. This is the most exciting one because the V flag actually indicates the error at the sign of the number. That means anytime the V flag is set, that means obviously you did not get a right answer for sure, and also the answer has a wrong sign. Okay? That means this indicates a sign error. Now what does it mean? This means that if your result should be positive, but you are getting probably the negative result. Or if your result should be negative, you are actually getting the positive results. Now you might be wondering how this is possible. This is actually possible in the digital math because of the representation of negative number. Because the way we represent the negative number, we don't use any sign. We just consider the leftmost bit is 1, that's negative. If the leftmost bit is 0, that's positive. So that's a different way of representing, and that mess up whole things, okay? Let me show you a couple of quick examples, then you probably will realize. But before I go to the examples, let's look at the V flag a little bit more clearly. Now this is exactly, this also tells you how we know that the flags are set in case of addition and subtraction. In case of addition, we have two conditions. Now here are the conditions. If both numbers here are positive, and you are doing an addition, but you got a negative sum. You see what I'm saying? You are adding two positive numbers, but your result is negative. You might be wondering, is this really possible? That's not actually possible in the traditional math, but that's possible in the digital math. We'll show you example, okay? It's because of the representation of negative number. Now, same here, if you are adding to negative number and you end up having a positive sum. In these two cases, in case of addition, your V flag is set. Let's check the subtraction. In case of subtraction, look at these two numbers. You know the first number is called minuend, right? And the second number is called subtrahend. Now you see here, the minuend and subtrahend have the different sign, right? One is positive, another one is negative. But subtrahend and the difference have the same sign. So this is one case when, this is the case when your V flag is set in case of subtraction. That means your minuend and subtrahend have different sign, but the subtrahend and the difference have the same sign. Same is here. Look at this. Your minuend and subtrahend has different sign, right? Have different sign, but the subtrahend and the difference have the same sign. These are the two cases in case of subtraction when the V flag is set. Any question? It's really interesting, but we'll see, more closely when we'll look at the example, okay?
So the only time those two are going to have the same sign is when the flag is set.
Say it again.
The only time the subtrahend and the difference are going to have the same sign is when the flag is set.
You are telling reverse. If this happens, then V flag is set. See, V flag depends on this, okay? Flag is the indicator that you got something which is not right, okay? When something like this happens, meaning any of these two happens in case of subtraction, V flag is set, okay? So V flag actually depends on the result like this, okay? Let me show you another condition which tells you what happens or how the V flag is affected when the operation is not an addition, not a subtraction. Because operation can be something else, right? It may not be an addition, maybe it may not be a subtraction. Now if it is something other than addition and subtraction, we have a straight formula. Now the formula is N flag, exclusive OR, C flag. Do you remember what is the exclusive OR gate in digital circuit class? Exclusive OR gate gives you high when both inputs are different, meaning the opposite, okay? That means if the N flag is set but the C flag is cleared, or if the N flag is cleared, C flag is set, then V flag is set. Again, this is only in case of the operation which are not addition or subtraction. Because you know the rules for the addition and subtraction, right? In the previous slide, you have seen the rules. This is for the case when you are doing some other operation which is not an addition or not a subtraction, but you are trying to determine the result, the outcome of the operation, and also the V flag based on the operation. Okay? Be careful. In case of addition and subtraction, rules still apply, the previous rules, okay, that you have seen in the previous slides. Let's look at a couple of quick examples to understand how the flags work. But before we go to the example, let me show you a little bit more detail about the flag and how do you know about the flag from our instruction set. As you know that our instruction set, we have plenty of information. So the first question that we want to ask, do all instructions affect N, Z, C, V and C flags? Answer is no, okay? Meaning some instructions affect some flags. Some instructions do not affect some flags. How do I know it? We actually know it from the very last 4 columns of the instruction set. You see here I actually made a rectangle highlighting those 4 columns at the very right side of your instruction set. So for each instruction, you have these 4 columns at the very right side. That actually tells you which flag is affected by this operation, meaning by this instruction. Okay. Now we have several symbols there on in the flag flag list. Now if there is a triangle, a small triangle, that means this flag is affected by this instruction. Okay. If there is a dash or hyphen, that means the flag is not affected by the instruction. That means no matter what happens in the instruction, flag will remain unchanged, this flag. Okay. If there is a 0, that means this flag is cleared by this instruction no matter what is the outcome of the instruction. Okay. Because some instruction always make it 0 no matter what is the output of the instruction. And same is here. If the flag is 1, that means no matter what happens, this flag is always set by the instruction. For an example, we have an instruction here, AND A. If you look at the very rightmost 4 columns, what do you know for this instruction? You know that AND flag is affected by this instruction. That means that AND flag can be either 0 or 1 based on the outcome, right? Z flag is affected by this instruction. That means Z flag can be 0 or 1 based on the outcome of the operation of this instruction. V flag is 0. That means what? That means no matter what is the outcome of this operation, V flag will always be cleared by this instruction. No matter what is the outcome, it will be always cleared. Okay? And the C flag will remain unchanged because of this instruction. That means if C flag were 1 before this instruction, it will still remain 1. If the C flag were 0 before this instruction, it will still remain 0 because it was unchanged. Nothing will, C flag is not affected by this instruction. So that's how we can read, and we'll know pretty much which flags are affected by which instruction out of these 4.
Is obviously going to be negative, but it should also be a carry.
Okay, let's look at the examples because I'm saying let's look at the example for everybody else. Yeah, so then probably we can discuss the answer. Okay. Now let's look at a couple of examples. Here is our first example. You are adding. Let's say we are adding 2 numbers. Okay. 2a plus 2a. Now, can we tell which flags will be set or cleared? Meaning out of those 4 because of this instruction. Now if you add these 2 numbers, you get 54, right? Let's look at the flags. N flag is 0. Why? Because your answer is not negative, right? It's a positive number. Do you see the answer? What is the answer? 54, right? 54 is a positive number. How can I tell 54 is a positive number? Because the leftmost digit is less than 8. If it is 8 or more, then it's negative, right? So if it is not 8, so that's positive. So the negative flag is cleared. How about the 0 flag? It's cleared because the answer is not 0, as you can see. Yeah, it's not 0. Well, how about the carry flag? Remember, the carry flag is set in case of addition if you have a carry at the very end. There is no carry at the very end, right? So the carry flag is obviously 0. What happens to the V flag, which is more exciting one? See, the V flag, this is a positive number, right? 2a. This is also a positive number. This is also a positive number. So there is no problem with the sign. V flag is not set. So basically, all the flags are cleared, which is also an answer. Okay? We need to know whether those are cleared or set. Any question for this? For this example.
So I understand why the negative flag is not set. Can you run through the previous example?
Is it 0?
No, it's not.
So 0 flag is not set. Do you have a carry here at the end?
No.
So the carry flag is not set. And there is no sign error because both of the numbers are positive and the result is also positive. So that means this doesn't fall any of the 4 categories. Remember, there are actually 4 categories for which the V flag is set. Remember the slide? We have 2 categories for addition. We have 2 categories for subtraction. Those are the only 2 categories when the V flag is set. Okay? If that do not match, the carry flag will not set. I'm saying the V flag will not set. Let's look at another example. We're trying to add these 2 numbers, 91 plus 91. Okay? Now here is the answer we got. Can you check this answer? Is this right? 1, 2, 2. Okay. Now, first of all, This is not a negative number. How can I tell? Because the answer is actually 22, right? Because the 1 is dropped, that is like carry, right? The answer is 22, which is not a negative number, right? So it's 0, meaning that negative flag is 0. Zero flag is also 0 because the result is not 0, right? Zero flag is only set when the result is an absolute 0, 0, 0, right? Carry flag is set. Why? Because as you can see, there is a carry, right? See, there is a carry, right? At the end, this carry. So the carry flag is set. What happened to the V flag? Now let's check the answer, then you will know why the V flag is set. Look at the number here. Is this a negative or positive number? 91. It's a negative number, right? This is also a negative number. So you are actually adding two negative numbers. What is the result? 22. It's a positive number, right? So V flag is set because that fall in one of the 4 categories, right? Both numbers have the same sign. Result has a different sign. Yeah. In case of addition. Yeah. Any question about the V flag? I'm sure that you like the V flag most very soon. Let's look at another example. Okay? Now we are doing a subtraction. B1 minus 7C. Okay? Let's do the subtraction. The result we got is 35, right? Let's look at N flag. It's 0, right? Why? Because the result is 35, which is a positive number, right? Why is a positive number? Because the leftmost digit is 3. It's less than 8. Zero flag is 0 because the result is not 0. There is no carry or borrow because this is subtraction. There is no borrow, so it's 0. What happened to V flag? V flag looks like set.
The B is considered negative. It's not, it's where you're
Okay.
you're subtracting.
No. Why the V flag is set? Remember, you have to always think about those 4 categories we have on the list. This is a negative number, right? And this is a positive number.
Yes.
That means minuend and subtrahend have different signs. Okay? But look at the subtrahend and the difference have the same sign, right? Remember, this was one of the category that minuend and subtrahend will have different sign, but the subtrahend and the answer, meaning the difference, will have the same sign, right? Because both of these are positive, right? But these 2 numbers have the different sign, B1 and 7C. So these actually fall into one of the 4 categories if you go back to the slide. So that's why the V flag is set.
I think I understand. You can still tell because it's B is a negative number and then you're subtracting 7C. So it's like you're adding 2 numbers.
Don't try to make any guess. Just follow those rules because there are some more surprises coming soon. Okay, so let's go to the. If we don't have any, do you have any question? I'm sure that you probably will have question. We'll be doing the quiz, and again we love quizzes. So let's go to the quiz section. Let's try our next quiz, which is quiz 7. In the quiz 7, in every question you will be given an addition or a subtraction. Okay? So you have to tell for every question which flags are set or cleared. Okay? Most of the question will be actually asking which flags will be set. But remember, some question have multiple answer because multiple flags can be set, right, at the same time. So some of the question have multiple answer. So you have to select all of those to get the full credit. But this is the easiest one for the flags because in every question you will have either an addition or a subtraction. So we'll look at some more operation in future, not in this one. Okay? Let's go to the quiz section. Let's try this flag quiz. But remember, these flags are really, really very important because we will use these flags to understand many other instructions and operations very soon. Let me stop this presentation here so that we can go to the quiz section and try our next quiz, which is quiz 7.